And we're going to do long division and synthetic division. Long division and synthetic division. Okay, here we are. So we're actually going to start with this problem. And I'm going to be very, very dramatic in how to do these long divisions. Like, imagine I was your fourth grade teacher. Hi, what's happening here, right? So what do we have over there? 2137? And I had 12 out here, correct? Let's walk through the process. So remember, division is opposite multiplication. We're saying what times 12 gets me close to being 2137, right? Everybody with me? So I'm asking myself, 12 times what gets me there? And I got to do it in pieces, don't I? 12 times what gets me to 2? Doesn't work, so I skip it over, don't I? Then what do? I say, well, how many times can 12 go into 21? Once. So I put a 1 up here. Okay. At this stage, I know this sounds ridiculous, but what do I do with that 1? I do 1 times 12, don't I? 1 times 12 is 12. What do we do? Why am I subtracting? That's not a negative 12. It's just the process, right? Because we're figuring out what's left over after I put into it, hence why we're subtracting. We've got to see what's kind of like the remainder of that. But the key thing there is I just go 1 times 12 and I subtract that result. That's important because that's what the part, and when I teach today, a lot of people struggle with. So just remember that though. What's left over? 9. And I shouldn't be able to go into that number already, should I? Because if not, I should have did higher, correct? Remember, so we're going to bring down the 3. How many times can 12 go into 93? 7 times. 8 would be too much, right, Daniel? So 7 times 12 is 84. And this would be 9, d7. Once again, I'm bringing down my terms with me, right? Okay, I say, okay, how many times can 12 go into 97? Now say it, Daniel. 8. I'm left over with a 1. Now, we also remember seeing that we could actually put a decimal and have unlimited zeros. What I'm going to do this is just remainder 1, correct? What's another way I could write this? I could say that's 178 plus 12. Okay? Remainder my 1 divided by what I was. Or 178 and a 12. Is everybody with me? Because isn't that what really the remainder 1 is? It's just a leftover fractional, correct? Is everybody with me on that? How do we feel on our long division? Are we okay? All right, yes, sir. Oh, that you were good to go. Okay, here we go. Well, let's do it with the polynomial. Okay. So we're going to use this as a polynomial, but we're going to treat it just the same way. Little side note. How many of you guys remember when I was like at 37 going into 290 like that? What'd you guys do? Just think about what your process was. You guys know your 37 times tables? I don't know them. So what did I kind of do? I'm like, all right, that's kind of like 30 or 40. I kind of rounded. Is that kind of what you guys did? Yes, no? That's kind of what I did. I kind of ignored the 7. And I'm like, 30. How many times can 30 go into that? Oh, probably 9 times. And I'd try it. Or I'd say, this is 40. How many times can 40 go into 296? Oh, 7 times. You get what I'm saying. But I'd try one way or the other. I'd round. I'd kind of ignore the 7 and I'd do a 30 or a 40. Okay? The reason why I bring that up is because when I'm doing long division here, I kind of ignore that -2 like a redhead stepchild. You're a stepchild? Hopefully you're not. I am. I'm a Chingy, though. I'm not a redhead stepchild. I am a stepchild. All my siblings are redhead stepchild. And yes, they got ignored. My mother's like, oh, I love you. Anyway, how does x become x squared? We're doing the same process. We're asking, X times what gives me x squared? X. Okay, I'm going to go very elementary. What did we do when we went and had division? After we got that number, what did we do? We took that number and multiplied it in, did we not? So I take x and I multiply it by x minus 2, which is x squared minus 2x. All agreed. You see how it's so far? Same exact thing, right? Now, what did I do with that 12? But it wasn't, 1 times 12 wasn't a negative 12. I had to subtract that 12, right? Okay? So I have to subtract that polynomial, don't I? And when I subtract that polynomial, I need to make sure I do it to both of them and not just the front one. Do you guys agree with that? So what do we have to do? Distribute it in. So isn't that basically negative x squared plus 2x? Or I just switch my sign? So understand, I'm going to get this polynomial, and all I really have to do is just switch my sign. But why am I switching my sign? Because that's equivalent to subtracting that polynomial. Does that make sense to everybody? What's happening there? That's usually the biggest thing people forget to do, is subtract it. But it should be the same procedure. It's just like our other long division, right? Okay. So, ladies and gentlemen, here we go. What's x squared minus x squared? 0. What's x plus 2x? Okay, then I'm here. And then I say to myself, what is x going into 3x? Positive 3, right? It takes me a positive 3 to get there. So I get 3x minus 6, but remember I'm subtracting this, so what do? Switch the signs. That's all it really is just switching the signs. Why am I switching the signs again? I'm going to bring this up a lot. Get it in your head. It's technically me just subtracting that polynomial, right? So what do we get? Because I don't have any remainder, do I? Ladies and gentlemen, if I but distribute x plus 3 by x minus 2, what would I get there? Okay. So we're going to be doing division using polynomials. You guys ready for another one? Pretty easy, right? Nothing like out of the ordinary. Really, it's just like longhand, long division, except you have to play with some variables instead of just numbers. Okay. How about this guy? He's a little bit bigger. Oops. Okay. Our goal is to find f of x divided by g of x. Okay? F of x divided by g of x. So, okay. So as I'm working on this, I do the same thing as I did last time. Okay, where I have x squared plus x minus 1 goes into x to the 5th plus x to the 4th minus 2x cubed. Notice, what am I missing though? I'm missing an x squared term. Ladies and gentlemen, I still want to have a placeholder there. So isn't 0x squared the same idea as nothing there? Okay. You ready to rock and roll? go. How many times can x squared go into x to the fifth? X cubed, right? We need x cubed to get there, don't I? Agree with me on that? Okay, here we go. Take this number, multiply it by this. That's exactly what I do in normal long division, right? So I have x to the fifth plus x to the fourth minus x cubed. So once again, I need to negate it, so I'm switching my signs. Everybody understand where I did that? Once again, why am I switching my signs? Because I am subtracting the polynomial, right? Did you get x to the fifth is gone. X to the fourth minus x to the fourth, gone. Negative 2x cubed plus x cubed, negative x cubed. Bring down the 0x squared, the plus x plus the 1. I bring everything down to come with my power play, just so I don't lose them. Okay? Do I have to bring everything down? No. Does everybody understand why I don't have any x to the fourth? Because they got rid of each other every. Okay. How many times can x squared go into negative x cubed? Just one? Negative 1? Negative x? I like that better. Negative x times. I'm going to scroll down just a little bit. Negative x, so I have negative x times x squared, which is negative x cubed. Ladies and gentlemen, this is exactly the reason why you want to go ahead and make sure something's there, because I have negative x times a negative x, a positive x, which is negative x squared. Notice I want to have something line up with it, right? Negative x times negative 1 is a positive x. Switch my signs, right? Everybody agree with me? That becomes a positive, a negative. So those guys are gone. I'm gone. That's a x squared. Those guys are gone, correct? The x terms are gone. Did we see that? Plus 1. Any questions so far? Still probably want to put a placeholder here, though. How many times can x squared become x squared? 1. When I do so, 1 times x squared becomes x squared. 1 times x becomes x. 1 times negative 1 becomes negative 1, but I'm going to go ahead and subtract. Right? Gone. Negative x plus 2. Our remainder. Why is it our remainder there? Can x squared go into x? No. I mean, I could times it by 1 over x, but yeah, I'm not going to. Okay? So I can't go into it anymore, so that's my remainder. So how am I going to write this? So you guys have this down that you can at least out for me, right? So it is x cubed plus x or minus x? Minus x plus 1 plus, what was our remainder? Negative x plus 2 over x squared plus x minus 1. That would be our answer of f of x divided by g of x. In last class, I had somebody, Mr. Roberts, why the heck are we doing, what's the purpose of dividing polynomials? Well, there's times that we are going to do, actually a lot in our next unit. When we divide polynomials, we're going to have what we call asymptotes. When we get close to these asymptotes, okay, this is really what's happening. Is notice I have that graph, then I have that little extra part off to the side, the remainder part. And that's what gets really close. Not really, because I haven't really deep big, into it, but talk about it. Okay. Not too hard of a process, though, right? Just long division with variables instead of numbers. Okay? Now the key thing there is you'll notice I did it with a linear one. I did the very first one with a linear, didn't I? The second one I did it with a quadratic. Could I use an x to the fourth on long division? I could. Can I do, I can't do my next one I'm going to do, which is called synthetic division, unless, am I all right with you guys, isn't it? Synthetic division, the only time you can use synthetic division if it is a linear binomial. A linear binomial. Only time you can use synthetic division is by doing it with a linear binomial. So my question to you is this. My very first example, could I do it synthetic division? What did we divide by in my very first example? X minus 2. Is that a linear binomial? Yes. What was my second example? Was that my second example, the one I just did? That was a quadratic. That's not even linear. So could I do a synthetic division using that, guys? I could not. Okay, here's synthetic division. At first, I'm going to ask you just to trust me on the process, and I'm going to get a little deeper as I talk about it. But kind of just bear with me, and you're like going to think, what the crikey? But in the end, you're going to love him like the little unborn child that you guys all have. Okay? Coming up, you're going to love it, I promise. As soon as they pop out, you're like, oh, I love you. It doesn't happen. It's like instantaneous. You're like, I want to save you forever. No? You'll feel it. Maybe more. I'll shut up. Okay, here we go. So treat it just like this is going to be the thing you use. This is the one I would use synthetic over long division every single time. I'm telling you right now. It's a much simpler process. What was my first example again? I think I had x squared plus x minus 6 divided by x minus 2. Right? Everybody there with me? Okay. When you use synthetic division, what you're going through is you're just looking at the coefficients. What's the coefficients of my quadratic? 1, 1, negative 6. Not just my leading coefficient, all my coefficients of the quadratic. Does that make sense to everybody where the 1, 1, negative 6 came from? Notice I have the leading coefficient, which is 1, which is in front of my quadratic term. I have a 1 that's in front of my linear term, and then the negative 6, which is my constant. Right? Does everybody understand where I'm coming from there? Okay. So, now I'm going to draw this little bar right here. Just bear with me. You're like, what the heck is this little bar? It's like our division bar, but it's different. Okay, and notice I put it right below my leading coefficient. Okay. What I do now is I ask myself, what value makes this guy 0? Positive 2. So, if you recall, when we just did long division, I had to subtract, didn't I? I would times the two numbers and I would subtract. But because kind of in a way, I've already negated my division problem, because notice on top it's x minus 2, but what am I dividing by? 2, so it's kind of like the opposite of what I already see. Makes sense to everybody? I don't have to subtract, I'm going to add. Now, bear with me right here, I'm going to show you how we do it, and then I'm going to talk about it. Take this number, hence why there's a line here, just bring him straight down. Okay, and here's what we're going to do. We're going to go 2 times 1. That's 2 times 1. What are we going to do here? Add. That's 1 plus 2. What are we going to do? Times, right? Which is add, and what do we get? Okay, let me explain something now. If you guys truly look at your first example, all these numbers right here are on those. 1x squared plus x minus 6. Okay. How many times can x go into x squared? 1 time. And I'd have x squared plus 2x, did I not? Or negative x squared plus 2x after I switch my sign, correct? There's that number. You want the x squared to cancel, and I'm left with that. You know, it doesn't really make sense right now for a minute. Well, what? 1x plus 2x. Oh, 3. And then notice I went on. There's your other numbers that the negative 6 and the 6 cancel out as well, right? They're all kind of there. Now let's explain what just happened here. Ladies and gentlemen, what was my result of that first guy? X plus 3 was it. So, now let me get a little deeper and talk about this. Because right now you're like this, no, I can see how you did it. Most of you guys can see the numbers and what I did, right? Just times, added, blah, blah, blah. But let's talk about what this means. Remember, when I do synthetic, what does this have to be? A linear binomial, correct? So when I'm dividing something by a linear binomial, okay, how many times does it take x to get into x squared? It'll always be x times whatever coefficient this is, right? It'll be x times that coefficient. Okay, meaning if this was x squared, yeah, it's just going to be an x. But what if it's x to the 4th? Okay, it would be 1x cubed. Notice the 1, or the coefficient, just comes down. But anytime I divide by a linear binomial, am I not going down 1 degree? My answer would be 1 degree less than what it was. Think about it. If I had x to the 4th, and I'm dividing by something by x, wouldn't my result be x plus minus 2 times something cubic to get x to the 4th? Let me say that one more time. Linear binomial, the x plus or minus something, times what would give me x to the 4th? It would have to be an x cubed, wouldn't it? So all that does is it takes us down a notch. This was x squared, what's this? X. If I had x to the 4th, what would this be? X cubed. So it just brings us down a degree. Okay, that's why this works. Now, remember how the other day we had that one factoring problem that we couldn't factor? You guys remember doing that one? But I'm like, hey, sooner or later we're going to have to find those zeros. Synthetic division is how we find those zeros. And so we'll be using it a little bit deeper. But really, all this is saying is, okay, I went from x squared down into terms of x. So therefore, that's x, and that's my constant. This is my remainder. With me. Should we try another one? Okay, you guys ready? Do another one. All right. Now, could I do this long division? I could. If I raced you, I'd kick your butt and take your name. I'd take like probably 4 of these problems by the time you get done. Okay, this is just a quicker result to long division. But once again, it has its restrictions. What can we only divide by? Linear binomial. Right? Is everybody with me there? Okay, here we go. What's our coefficient? 3, 5, negative 4. We still have to have the x squared, so we put a placeholder. Good job, James. Notice, constant, linear, x squared, x cubed, x to the 4th, x to the 5th. If I don't have that placeholder, it would actually say I'm just using an x to the 4th, right? Because once again, there's no x squared. So it's the placeholder. You should always be able to go right to left and have the exact same thing. Constant, linear, quadratic, cubic, quartic, fifth degree. If I didn't have that, look what I'd have. Linear, excuse me, Sophia. Here we go. Constant, linear, quadratic, but he's not a quadratic, is he? You see how that placeholder is very important? Okay, so when I divide this, what is it going to come down in terms of? When I'm done, what is this going to be in terms of? X to the fourth, because I'm coming down 1 degree. Why am I coming down 1 degree? Because this is a linear binomial, and how many times does it take x to get into 3x to the fifth? 3 times, right? 3x to the fourth time. Hence why you bring him straight down. Is that making more sense? Okay, what's the number that I'm dividing by? What number? 4. Does everybody understand why it's 4? Because it's the value that makes him 0. Right? Is it always a positive number? Could it be a fractional number? Could it be an imaginary number? We'll get to those later. They're fun. Not today, though. Huh? Now, when I'm saying that, the problem about, okay, I will bring this up. Because a lot of times the fractional comes from, like, let's say I have the 3 here. Okay? I can find my zeros, which we're not working on today. That's not our goal today, Hadley. But I can find my zeros doing that, but it's not true division. Because when I go through it in that case, let me ask you this question. If I had 3x minus 4 and x minus 4/3, what are the values that make those guys 0? 4/3. They both have the same 0 at 4/3, don't they? But isn't this and this 2 different things to divide by? So it is a difference. It could be a different depending on how it was written. So it might not be true division, but it could help us find something out a little bit. And I'll talk about that a little bit later. But right now, most of your things that you're doing today is just full numbers. Okay. All right. So, not to confuse people on the notes when we get there. Okay. So what do we do to this process? Once again, we're going to go 4 times 3. Just always bring the front guy down. And once again, here's the reasoning again. How many times can x go into 3x to the fifth? That's what this is going to be. Hence the first one, because this is always going to be a 1. That's kind of our goal. Even if it wasn't a 1, that's where it gets tricky. And I can get into that deeper a little later, but not today. But right now, we're always going to basically have a leading coefficient with a slope of 1 right now. Okay? So a 3. 4 times 3? 12. 5 plus 12. Now, once again, why am I not subtracting? I'm adding because I've already taken care of the negation by adding him over type of a deal, right? Does that make sense? 4 times 17, 68. That's 64. It's 256, I believe. Am I correct in that statement? That's 256. That's 1,024. 1,031. That's 4,124, I want to say. Am I right in that? And then so 4,127 would be my remainder. Because once again, what does this represent? 3x to the fourth. Let's go ahead and write it. 3x to the fourth plus 17x cubed plus 64x squared plus 256x plus 1,031, but we had a remainder of 4,127 divided by x minus 4. Okay. If I times x minus 4 by this whole stuff, guess what I get? Get that. Anyone want to do it? Neither do I. Okay, but it would work. Okay? Now, I want to show you something pretty interesting. Remember this number. Can somebody read me the one that I had on top? It was 3x to the, yes sir. 4127?
So I understand where the 300 came from, but then
Because remember, just like we did on our very first division problem that we did the old school one, remember your remainder, what do we actually do with it? Because it's not really, I mean, I remember doing it. Oh, my answer's 178 remainder 1. No. Really, what does that mean? It's 178 and 112. You take the remainder and divide by what you divided by, correct?
yeah, how do you find those remainder?
So the remainder, to answer your question, Daniel, is just whatever the last term is. If you'll notice our first example that we did, it came out to be remainder 0. So that means it was a perfect factor. Huh. That makes sense to you, Daniel?
Yeah.
So this was a remainder of 0.
Okay.
Answer your question?
Yeah.
Okay, thank you, Daniel. Okay, so I had 3x to the 5th. What else do we have? We're using that same thing. What is it? 5x to the 4th cubed. We'll call him f of x really quick. We divided by 4, didn't we? Our sentence was 4. Ladies and gentlemen, I'd like you to tell me what f of 4 is. How do we do that from what we already know from the past? We'd go like this, right? We'd go 3 times 4 to the 5th plus 5 times 4 to the 4th minus 4 times 4 cubed plus 7 times 4 plus 3, right? Would we not do that? Does anybody know what 4 to the 5th is? Let me think about that. 16 times 16, 256 times by 4 again is 1,024 times by 3 is 3,072. Okay. Am I right on that, by the way? Everybody do it? Were you impressed? A little bit. You're a little jealous of my mind right there. It's just tricks that I've learned. Okay. 4 to the 4th is 256 times by 5. 1250 plus. Oh yes, Dingleberry. 256 plus. Hold on. Nobody tell me. I don't know why I'm struggling. 286? No, hold on. 1286. 1280? Now you're like, he's like us. That right there is just 256. That's just 28 plus 3. What does that come out to be when you add it all up? 27 or 47? 47? Oh, good, because that's what it's supposed to be. Oh, good. I was like, I swear my thing was 20. Right. Ladies and gentlemen, it's the exact same thing as our remainder. Oh, okay. Granted. This sucked. Right? Did that not suck finding this? Was this really that bad by plugging 4 through? I could do that in my head almost. Because they're not as large numbers, are they? You can find the value of a function by doing synthetic. And that's actually very important because we're going to get into that a little bit more after we test. We're going to jump into this stuff deeper, but this is just a good time to stop. We'll have one more lesson next time. This was supposed to be our last lesson of the thing, but I switched them up. Okay? And we're going to talk more after the test about why that's important. But it's called the remainder theorem. So, once again, if I want to know, okay, if I had 3x squared plus 4x minus 7, okay, and I want to divide that by x plus 3. No, I don't even need to divide by x plus 3. I don't even know why I'm asking that. Stop. Don't do that. If I want you to find, f of, what did I tell about before I erased it? So that'd be f of negative 3, right? I could plug it in. I really could. But when it gets to higher powers, that becomes a little crazy, doesn't it? So therefore, just do synthetic. Watch how fast it becomes. Baby. To me, that's faster than having to plug it in. You guys agree? And that's what the remainder theorem says. Whatever your remainder is the value of you putting it into the function. So if it's remainder 0, what does that mean? There's no remainder, right? Which means your point is on the x-axis, which helps us find our zeros, which we're going to get deeper in next time. Okay? How do we feel? Not too bad? Let me just show you one more, okay? And then we'll be done. Oh, no, where's my paper? Oh, no. I wish this one didn't come out the way it did, but it did. Ladies and gentlemen, I want this factored completely. Okay? Now I could have factored this one. This is one I actually know how to do by, this one is, if everybody can recall, those guys group. I can plot an x squared, factor by grouping, it actually works. A little disappointed that's the one I made. We could try another one, I guess. But we'll do this one. I'm going to show you how to factor completely using synthetic division. This guy right here is what we call a factor. I'm already telling you he is a factor. So that means he goes into a perfect group. That's what a factor is, right? What's something that's a factor of 24? 6 is a factor of 24, right? 5 is not a factor. That would give me a remainder, right? 6 means it goes in perfectly. A factor means they go in perfectly. So what should that mean with my remainder? If I do this division, what should it come out to be? A 0. Yeah. Oh, yep, that should be a 3x squared. Thank you. Oh my, that darn hornet. It's so bad. So once again, what's my coefficients? 1, 3, -1, -3. Agreed? Everybody there with me? Here we go. What's the thing I'm going to divide by? 1. Because, once again, that's the value that makes it 0, correct? 1 times 1. 1. 1 times 1 plus 3 is 4. 4 times 1 is 4. That's positive 3. I'm like, something just went wrong. What's 1 times 3? -3 plus 3. Which I already told you he was a factor, right? And it shows that he is a factor. How? Because there's no remainder. Make sense? Everybody understand what a factor means? Okay. So first off, let me just go through again. 1. 1 times 1 is 1. 4. 1 times 4 is 4. 3. 1 times 3 is 3. You with me there for a bit? Okay. Hey, by the way, good job being on time lately. Yeah, I didn't give you your clap outs there. Ladies and gentlemen, if this was an X cube, what is this? Give me 1 second, I'll finish up first. If this is an X cube, what does this mean? Ladies and gentlemen, what can we always do at this stage? Either factor or quadratic formula. We can put those answers in terms of linear factors if we needed, couldn't we? Right? Just put them in terms of factors. So we factor him to be x plus 3x plus 1, and what was already one of our factors that was already given to us. Yep. So therefore, if I did this by this by this, I should get the result that we have. And that's the nice thing about this, is this allows us to keep solving if we can get down to a quadratic. And that's how we're going to be able to find all our zeros if we can come up after that. Okay? Because this unit is not even, like, we're cutting this unit in half. Could you imagine if we kept going, how much stuff would be in this sucker? A lot. So we're cutting this sucker in half. Okay. Okay.
So I'm not one more thing I always need to
Okay, no, ma'am, no. On some of it just says divide. So on some of them, you're just going to divide, and you might have a remainder. What do we do if it's a remainder? We add it just like we did, right? There's some questions in there that says, is this guy a factor? What does that mean? So if I did synthetic or long, what should I have if that's the case? Remainder of 0. Answer your question? And then some other ones, they'll ask you to factor completely like I just did. Some of them, they'll ask you to find f of a, where a is -2. That's basically doing the remainder thing. On your test, if I see you guys if I say find f of 3, and you do it the way I've already, like we all know how to do it by plugging it in wherever you're at, you think I'm going to give you a point? You're going to have to do it via remainder thing. It'll say use the remainder thing. So bear with me there, though. All right. So the remainder theorem, brother, is, well, remember after I go completely through. So for example, if I had this, 3x squared plus 4x minus 7, and I asked you to find f of -3. So basically, you just do synthetic division, okay? And whatever the remainder is the value of your y value. So we can even check it right here. Ready? -3 squared. 9 times 3. 27. Minus 12. 15. 15 minus 7 is? Okay. Because it's -3 times 4.
So that's
It's just whatever the remainder is that's the value of you plugging that into the function. Does that make sense? Okay. This really isn't a hard thing, but I think this is the thing that we need to practice the most. Right? Hence why I flip-flop 1, 6, and 1, 5. Just in case you guys have questions on it. It's not just, I have questions, but I'm testing today. Yeah. Right? You know what I mean? Is everybody with me on that? Okay, next time we'll be doing stuff like this. Just to give you a heads up. We'll be kind of going, we'll be solving guys like that. Looking for all their answers. Which we can do. I'll show you how. Okay? Does that make sense? Or we'll be doing something like this. Which we can do. Okay? That's what we'll be doing next time. Are we ready? Remember, how much of this review can you really do after this? I'd say 95% guaranteed that you can do 97. Let me see which ones you can. Front page, yes, 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 yes. Front page is all done. Yes. No. No. Yes, yes, yes. No, 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 no. Yes. 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 No. Yes. 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 So far, we can't do 3 of them.
A paper clip.
Kind of funny. We're all like, whose was it?
I don't know.
Okay, we're done. That's really, you can't do like